Let me introduce myself. My name is BX Hanifan with NIM 210531084 with lecturer Professor Dr. Tjokorda Tirta Nindhia, STMT, University of Udayana, and Mechanical Engineering. And today, I'm gonna explain you about metal forming process, about milling, screw threads, and broaching. The subject that I took from Handbook of Manufacturing Process, How Products, Components, and Material are Made, by James Gibrala. First one is milling. The milling process is a machining process that generally produces a flat plane. This flat plane is formed due to the movement of the machine table, where the process of reducing the workpiece material occurs due to the contact between the cutting tools rotating on the spindle with the workpiece grip on the machine table. Next one is face milling. Face milling is milling where the rotating axis of the cutting tools is perpendicular to the surface of the workpiece being milled. In face milling, there are two cutting edges, namely the cross-section of the cutting tools and the other circumference of the cutting tools. Face mills are primarily used for milling a face on the surface of plate or bar. They are predominantly used to cut with the end of the cutter rather than their sides. The term face refers to the creation of the flat face of the workpiece. Face mills often have a larger diameter than the width of the workpiece being faced, so that the surface can be processed in one pass.
Face milling is the process of machining a flat surface on a workpiece. A cutter is mounted to a face mill holder, which consists of an arbor, two drive keys, and a retaining bolt. Carbide inserts are secured to the cutter with screws. A face mill with positive axial rake reduces cutting forces and vibration. The milling head should be positioned close to the workpiece to minimize quill extension and maximize rigidity. Locking the gibs on the Y and Z axes will further improve rigidity. Steel and brass materials can be cut dry, while aluminum, stainless steel, and titanium should be cut with an appropriate lubricant.
Next one is peripheral milling. Peripheral milling is a machining process in which the milling cutter is placed parallel to the workpiece. In other words, the milling cutter is positioned so that the side of the cutter grind away at the top of the workpiece. This is in a stark contrast to face milling, in which the very tip of the cutter pressed against the workpiece. Peripheral milling generates a surface parallel to the axis rotation. Both flat and firm surface can be produced by this method, with the cross-section of the resulting surface corresponding to the axial contour of the cutter. The process is sometimes referred to as slab milling. Next one is end milling. End milling process consists of cylindrical cutter that has multiple cutting edges on both its peripherally and its tip. For mating and cutting and peripheral cutting, these cutting edges or flutes are usually made helical to reduce the impact that occurs when each flute engages the workpiece. End mills are used for making shape and hold in workpiece during milling, profiling, contouring, slotting, contour boring, drilling, and reaming. They are designed with cutting teeth on the face of the edge of the body and can be used to cut variety of material in several directions. Next one is slab milling. It's peripheral milling with cutter that produces a flat surface over a wide area. An axis of rotation parallel to the machine surface. The cutter often removes large amount of material. Sometimes 2 or more cutters are used per arbor with opposing helix. To balance cutting force is the process of using a tool to remove material from the surface of the workpiece. The aim of milling is to give a workpiece a smooth and flat face. Next one is form milling. Form milling is a type of CNC operation which is ideal for shaping irregular contours, including a curve and sometimes straight line. All this is done in a single cut using form milling cutter. These cutters are shaped with special irregular contours, so they can be concave, convex, or any other shape they need to get job done because of how specialized the form milling process is. Though it may be worth knowing that the machine speed of form milling can be 20 to 30% slower than the irregular milling. Next one is gang milling. It's simply milling with more than one cutter on the arbor of milling machine. This produces multiple surfaces of the workpiece with one pass of the cutter. Also see straddle milling as follows. Next one is straddle milling. When 2 or more parallel vertical surfaces machined at a single cut, the operation is called straddle milling. Straddle milling is accomplished by mounting 2 side milling cutters on the same arbor, set apart at the exact spacing. 2 sides of the workpiece are machined simultaneously, and final white dimensions are exactly controlled. As we can see in this video, two sides of the workpiece is machined by the straddle milling. Next one is fly cutter milling. Fly cutter is a single point rotary cutting tool primarily used on a milling machine for machining large and flat surface. The fly cutter is composed of a body into which 1 or 2 tool bits are inserted. Fly cutters are often utilized to remove large amount of metal and level it. Even though the tool is used for a long time, you can resharpen it by straightforward grinding. You can see the super fly cutter.
Hi, I'm Mike Corliss from Tormach, and today I'm going to demo the Tormach Superfly Fly Cutter. This guy right here. We're going to do some cutting in some 60/60.
Next one is pin routing. A pin router is a great way to carve out decorative relief, custom fitted, recrease, and sign. And when you get right down to it, a pin router is very basic machine. There is a router bit then line ups with a small pin in the base. The pin help guides a template that attached to the bottom of the workpiece. Next one is spot facing. Spot facing is mechanical drilling or milling process. After the initial hole is drilled, a larger well or recast is drilled into a material that head of the screw or nail fit into this well. This allows the nail or screw to sit flush with the surface of the item that is drilled. Its purpose to provide the flat mounting surface for mating part, such a washer or pen head screw. You can see in this video,
look at spot
facing.
Spot facing is just cleaning up the top of a hole to let it
So spot facing is just make
drill
on the top of the drill.
and then we'll use a twist drill.
This side.
And then we'll use our counterboring tool to actually make the spot face. So just a little spot drill with the center drill. Follow that with the twist drill. Do some peg drilling, make a hole.
You can see in this process.
Spot facing is used a lot of times on casting when the surface is uneven to help the fastener to sit down.
And this is the process of make a
surface.
spot facing. Next one is screw thread. A screw thread is defined as a ridge of uniform section in the form of helix on either the external or internal surface of cylinder. Internal thread refers to those on nuts and tape hole, while external thread are those on bolt, stud, and screw. You can see in this image, this is what we call screw threads. First one from threading is hand-die external threading. These are called button on or acorn dies and are useful for cutting screw thread in prototype or limited quantity production. The die is placed on the end of the screw blank and it rotated with a wrench-like tool. It feeds itself forward at the lead rate of the screw as it cuts the thread. And you can see this video of process of hand-die external threading. This is what we call the die, external die. This is the process of making a thread with hand-die external. This is the thread result after hand-die external. Next one is internal thread tapping. Internal thread can be tapped by hand or with a machine. Thread taps are especially designed to use to cut a female portion of mating pair of metal fastener. A die, on the other hand, is a tool used to cut the male portion. Basically, taps are used to cut nuts and die are used to cut bolts. Next one is single point screw thread cutting. In single point threading, a solitary cutting head, often attached to lathe, moves linearly or horizontally to a piece which is rotating as the single cutting point moves down the length of the screw. It removes material to cut the thread. Thread cutting is process for generating thread. It is used for the production of thread on the outer surface of cylinder or on the inner surface of board. Tools used for thread cutting are the thread cutting die, the screw tape for serial production process called cold and hot forming. Next one is thread cutting die head. Are efficient, accurate, and widely used in production threading. They are used on all kinds of lathe and screw machine or on drill press and as part of special threading machine. They have set of insertable multi-tooth cutter that are changeable when different pitch of thread are to be machined or when the cutter needs resharpening. Next one is thread milling. Thread milling produces a thread with circular ramping movement of a rotating tool. The lateral movement of the tool in one revolution creates the thread pitch. Although not as widely used on thread turning, thread milling achieves high productivity in certain applications. Thread mills are used for cutting internal and external thread. They are ideal for threading exotic material and soft, non-ferrous alloy where tap break is often a problem. Thread mills also provide smaller cutting force, allowing for the threading of thin-walled parts. This is the thread milling process. You can see this process of thread milling. Run in the circle of the workpiece. This one is thread grinding. Is used when particularly accuracy and surface smoothness are required, when heat-treated workpieces are threaded, or when the material is otherwise difficult to machine. Threads are ground in stainless and tooled steel and its sintered iron component, particularly when they have been heat-treated for hardness or are used in precision application such as adjustment screw and feed screw. And this is the process of thread grinding. You can see this is the process of the making thread in while grinding. This one is thread rolling. Thread rolling is a metal forging process that forms thread into the mirror image of roller die. The process is different from metal cutting, grinding, and casing because it doesn't remove any metal from the workpiece. Instead, thread rolling uses hardened steel dies to displace a more ductile metal. It's a cold forming method for making external screw thread. The blank workpiece is rolled between opposing dies which have a negative screw thread profile. Strength, accuracy, economy, and fine surface finish are some of the advantages of thread rolling. In contrast to cutting or grinding thread, the rolling process allows for higher rate of production, lower material cost, and no chip or loss of metal. Next part is a broaching. Broaching is a machining process that uses a tooth tool to cut a specific shape or remove a specific area from the workpiece, many times on the internal diameter of the workpiece. The broach is commonly used inlaid or attached to the machine powered by hydraulic pressure. Machining process using a cutting tool with teeth that increase in size from front to back. In many cases, an entire surface or multiple surfaces can be finished in a single pass with a broaching. The technique is most often applied to finish hull, splints, and flat surface. The advantage of broaching is high production rate and low cycle. When operation replaced by broaching, broach has long life because each tooth takes only one small cut in single operation. And the last one is temperature of workpiece fairly constant, thus avoiding the error due to thermal stress. First one from broaching is internal broaching. Is a broaching method that pushes a tool completely through the workpiece, as opposed to surface broaching, which produces a hole that cuts the surface of the metal. Is machining by broaching the inside surface of a hole or other opening in the workpiece. The most common broaching operation produce keyway, key slot opening, lock, spline shape opening, and other non-run arrangement of hole in pulley, gears, or other parts that are to be fastened to shaft. Next one is external broaching. Use a cutting tool that has draft outward side to create a precision cut on the outside of the part. Whether you are creating gears, bolt, or other component, that exact shape and application of the broaching tool can vary. This is the video of process in internal and external broaching. First one is internal rotary broaching process. As we can see, the process is inside the workpiece. See, the process is done inside the workpiece. And next one is external rotary broaching. As we can see in this video, the process is did in the outside of the workpiece. Happen in the outside of the workpiece. Last one is spot broaching. Spot broaching refers to the process of cutting the entire outside diameter of the piece part using multiple broaches, which are held in a broach holder or pot. Use a ring or tubular shape broaching tool with the cutting tip on the inside. Normally, the workpiece is pushed through the tool with hydraulic force. The tool cuts the entire workpiece periphery in one pass. Machining of gear tip is typical application. And that's all from my presentation. Thank you.